Hello everybody. In this presentation I would like to give an information about introduction to crop simulation models and assessing the agricultural risks of climate change, DSSAT and craft models case. First of all, I would like to give a particularly warm welcome to those of you who don't know who I am. My name is Ömer Vanlı. I work at ITU, means Istanbul Technical University, as the research engineer. As my scientific background, I will say that I graduated from agricultural and environmental engineering departments, and then as PhD I graduated from geographical information system department. It means interdisciplinary. Actually, my interest in crop simulation models began with taking a 2-week course named Art of Modeling at the University of Wageningen in 2015. Then I started to my PhD thesis by collecting data on the test fields identified at Islahiye and Nurda counties, where they in the southeast of Turkey. About collecting the data, we need some detailed data, including weather data, both historic and projected ones. Soil data, which is prepared grid-based, and initial conditions, culture management like fertilizer and irrigation, and calibration, we need observed yield data. For a 9-month period in 2017 and 2018, I happily studied the DSSAT model with Professor Garrett Hugenboom and his team at the University of Florida, where is also carried out by them like DSSAT model, the craft model. And thanks to Tubitak scholarship for giving me this opportunity. Of course, I also attended to 2IMD workshop, which is about the economic side, organized by the AgMIP team at the University of Agriculture in Faisalabad, Pakistan, where I learned a lot of information about modeling from them, especially to Dr. Ishfaq Ahmad. After I returned to Istanbul from Florida, I gave a 1-week DSSAT course to the project engineers who is work at the Agricultural Research Institute in Ankara. During all this PhD process, I continued to work and study at the Tarbil project with my PhD supervisor, Professor Berk Üstündağ. In this slide, you can see the phenological growth process of the wheat field taken from Tarbil meteorological stations, which is provided most of my data. In 2022 and 2023, I served as a project assistant in the 2-stage DSSAT training, which was in between University of Florida and Ankara University, and financed by the US Mission Turkey institution. In the slide you can see first training participants and This in this slide also second training participants. And they also are the DSSAT training experts team, thanks to all of them. As a result of my intensive work at modeling issues, proceedings and posters were accepted and I presented at it at many international conferences and workshops. I am also pleased to say that my articles have been published in many international journals. Of course, projects in the different areas I have been involved in have also been carried out. By the way, I can only show summaries of some of these. If anyone is curious about it, they can stop the video and can check it. As you know, like all systems in nature, integrated agricultural systems are multi-factor and interrelated components. With these components that are closely related to each other, the same process occurs when we deal with, for example, wheat crops. For the growth of the wheat, the climate, soil management practices, and genetic properties are involved to this interaction. As a result, crop simulation modeling systems are used all over the world to calculate the products like biomass, raw materials, harvest yield, and byproducts. Unfortunately, while the natural system is working perfectly on its own, regional and global environmental problems such as climate change have emerged whenever unconscious human intervention occurs. The Intergovernmental Panel on Climate Change meets on a regular basis to review the current situation and decide at country level on possible measures. In this SAT model, especially in the last updated version, it has added a climate change tab to the application part. As you can see, simulation calculations can be made based on different carbon dioxide emissions scenarios in the environmental modification section. In addition, spatial analysis can be carried out by creating different cultures and field treatments in the same section. Finally, in this set, yield forecast can be made with different options in the simulation controls section on different dates. In this box plot, you can see, according to my climate change simulation results for Islahiya regions, wheat yields are decreasing both in the mid-century and end century for CMAP 5, and also according to Norda box plot is happening the same things. Before we go into the craft model, I would like to show you two slides that we need to know about grid-based analysis. Each arc minute is equal to 1 degree divided 60 pieces. And it means approximately 1,800 meters long. So 1 grid on 5 arc minute scale is 9 kilometers and 9 kilometers in size. And if we think of this grid as a point field, we need to feed every grid with a lot of data to do a good simulation and analysis. In this slide, you can also see the user interface of the grid-based craft model. And here you can see some data I have added for the wheat yield at this region, which is my study area. We add all the data like masking, fertilization, irrigation, one by one to the template where the grids have their ID. This article written by Dr. Shelia Wachtang provides detailed information about the craft model. As I said before, craft is a model that has 5 and 30 arc minute resolution. And it's a grid-based simulation. Each grid has one ID. There are 3 levels at the country, province, and county level where grids are evenly distributed over the administrative boundaries. Methodologically, it consists of 2 stages. The first is the calibration of each grid's simulated input data with the observed yield. In the second phase, the calibrated grids are run together with all the simulated grids to find the total yield forecast. The second article is about a study in northern Kazakhstan. This is again the impact of the wheat crops on climate change in effect in several regions under different RCP conditions. Under RCP 2.6, areas where wilt yields are partially low, it means yellow zones, cover only small area. Now, the other slide, you can see under RCP 4.5 conditions, areas where wheat yields are partially low, it means the same yellow zones, cover a slightly larger area. And the last one under RCP 8.5, areas where wheat yields were particularly low in the same yellow zones covered a very big large area. Okay, that's all. I want to thank you for your attention. I hope it can be useful, this presentation. Thank you. See you.